Hello, welcome back to LIVENODING. In this episode, I'll be sharing with you the breakdown of this box city. Basically, it's kind of like a culminations of previous LIVENODING. So this is pretty basic. So what we have here is a plane using geometry nodes, and the plane is scattering these buildings, and they're kind of they're stuck. They're on the floor, so they're grounded. But this building is actually being generated also using a bunch of boxes. All right, so let's take a look very quickly. So this is scattering this box city collection, and inside that collection is all this smaller building. Okay, so this smaller building is made up of geometry nodes, and each one of them can have a slightly different seed, and also I can control the minimum and maximum position of the box. On top of that, there's also an array, so each one of them is based on this array of points. So I can specify, okay, you're based on 20, for example, or more count of boxes, or less, but they're also being remeshed. So it's very interesting actually when Blender do this. So we only have we have 5 different buildings, and I can control the boxes that made up the building, like so. And each one of them actually has been remeshed. When you remesh, actually it keeps the data smaller for Blender, so it can handle something that's more complex, like this, like a plane. Because if I try to remove the remesh, it's all gonna be just boxes. Oops. So now, if I go back to the plane, this is actually a little bit, it eats more memory of Blender, but you can always do like another remesh for this big plane. So this is just like the basic example of boxes being randomized and scaled. But we can, like I said, we can specify the number of array. So this becoming really quite complex in itself, because each object can have different count of boxes. At the same time, it's actually having these geometry nodes that's unique for each one of the box. So this is like, the first one is randomizing the position, the second one is randomizing the scale. It's actually replacing, or we can also just use add. Oh, actually, in this case, replace or create. And then this is just an extra multiplier for the scale. So after we do that, we can remesh. Once it's remeshed, it's become more like a compact objects, even though it could be higher in poly count, but you can control also the voxel. This kind of experiment I'm doing. Once it's become like object like this, we can continue, actually can process this inside something like Sparta. So it's becoming quite interesting. So if you use get object data from this guy, get selection, post modifier on. So we have a new objects. This is being generated using Sparta, and we can do a little bit more, like for example, merge by distance. There, you see, this is almost like a decimate modifier in a way. So this is kind of a really interesting experiment. Once you have new objects, you can do more. Maybe I should show you. So if you just get the edge net, you can use polyline viewer. You can have something like that. Pretty interesting. And this is something that, of course, we can use inside geometry nodes. All right, so yeah, so that's basically kind of an idea, kind of the box city into something else completely, but it's using just a bunch of nodes. With geometry nodes, of course, you're still reliant on instance cube. So you start with instance cube and then you scatter the boxes because it cannot auto-generate it. With Sparta, you can kind of auto-generate. I made earlier recording. So with Sparta, you create box and you can generate mesh sphere and you can scale the box. And you can create like a random value and then combine it into vector, plug it into scale, and you can scatter it. You can create random boxes this way. Similarly, like geometry nodes, you actually do the same thing using point instance, which is can be more efficient in a way. But yeah, this is basically the whole process, and hopefully you'll find this interesting and useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.